Alright guys, we're going to start back up with some more examples of triangle congruency proofs. So here we are with number 6 from our packet. I'm going to set up my T-chart. Okay. So let's start digesting our diagram with our given information. I'm given that AB is parallel to CD. I've got the matching arrowheads, but I always like to just extend those parallel lines. So it helps me see those special angle relationships set up by parallel lines and that transversal. Okay, so I know I'm going to be using, whenever they give me parallel lines, I'm going to be using some sort of alternate interior angles or any of that kind of stuff. Yeah. Okay, now they're also telling me that AB is congruent to CD. All right, so now let me think. What notation can I add here? Well, I know that CB is congruent to CB from the reflexive. That's what allowed me to add that notation. I also know that this angle and this angle are congruent by alternate interior angles theorem. Oh, and would you look at that? Now I can see that on this triangle I have a side, an angle, and a side, and I have the corresponding side, angle, side on the other triangle. So I know I'm going to use side, angle, side, triangle congruency, and I'm ready to start writing my proof now. So I'm going to start with that given information that I used first, which is AB is parallel to CD. Well, that did allow me to say that, because of those parallel lines, I've got that angle DCB is congruent to angle ABC. And that was alternate interior angles theorem. Wonderful. Okay. They also gave me the information that AB is congruent to CD. Now, the order of this stuff does not have to be exactly in this order. Just try to think about what would be most logical. Then I also added some more notation to say that CB is congruent to BC. And I used the reflexive property of congruency to make that statement. Once I did all of that, I've used this, I've used this, I used all my given, I'm ready to state. Triangle ABC is congruent to triangle DCB. I'm writing it just as my statement here says to prove. It's my last statement. And the reason is my side, angle, side, triangle congruency theorem. If you need to digest that, pause it, look through it some more, and come back and we'll look at the next example. All right, I'm going to set up my T-chart for my statements and my reasons. Okay. Statements and reasons. Now this is not, I'm just going to tell you, I've already worked it out, so it's a little bit long. Well, let's think about it. Start digesting. AB is perpendicular to AD. So AB is perpendicular to AD. So I've got this right angle. I'm going to have to make a statement about that. DE is perpendicular to AD. So I've got this right angle. I'm going to have to make a statement about that. All right. Now they've also told me here that C is the midpoint of BE. So there's C. It's the midpoint of BE, so that makes this and this congruent. I'm looking at this, guys. Okay. So now what else can I add? I don't have enough yet to prove those triangles are congruent, which is what I'm trying to do, but I could add that I've got vertical angles there. And those verticals are always congruent by the vertical angle theorem. And once I do that, I've got an angle, angle, followed by a side. And I have the same angle, angle, side on the other triangle. So I know I can prove the triangles are congruent using that. Now it's time to get started on writing my proof. So I'm going to start off that AB is perpendicular to AD and DE is perpendicular to AD. This was my given information. Because of that, I know I was able to add that right angle notation. I know that angle BAC and angle EDC are right angles. That's based off of that given information. I'm using the definition of perpendicular. It says they form right angles. Well, that leads me to be able to say that angle BAC is congruent to angle EDC. All right angles are congruent. That's actually the right angle congruency theorem. That's what it states. All right. So I've used up that given information. That was what it allowed me to come to. Then I have we're given that C is midpoint of BE. Well, if they tell me something's the midpoint, I got to use that midpoint definition. So BC is congruent to EC. And that is by definition of midpoint. All right. Used up all my given information. I did add some notation. I added the angle BCA was congruent to angle ECD. I was able to add that because of my vertical angles theorem. Which states that all vertical angles are congruent. And then once I did that, I was able to go, oh, triangle ABC is indeed congruent to triangle DEC, and it was by angle, angle, side, triangle congruency. You may need to pause and digest that a little bit before we move on to some more proofs. Okay, with these, it's going to be a little bit shorter, hopefully. I'm just going to draw in my little T-chart. Statements and reasons. And let's start thinking about working through this. It says segment AD bisects, so I'm going to have to use definition of bisects, angles BAC, so I know that that's congruent, and BDC, so I know these are congruent. I've got two angles already congruent. I also know that this right here is congruent because of my reflexive. I've got angle, side, angle, and I have the corresponding on the other triangle. So I'm ready to actually get started. I'm going to have AD bisects angle BAC and angle BDC. That is my given. With that given information, I was able to add notation to the diagram that angle BAD was congruent to angle CAD, and I added that angle BDA was congruent to angle CDA. And this is a 1. And that would be my definition of bisects. Okay, then I added in the AD was congruent to AD with my reflexive property of congruency. And then finally I can make my statement that triangle ABD is congruent to triangle ACD. And I knew that's because of angle, side, angle, triangle, congruency theorem. Okay guys, it looks like I'm going to run out of time again before I can finish the next couple of proofs. Join me in the next video where we're going to go over 2 through 5.